Now question 18. So we have been given a function f of x equals to x to the power alpha plus 1 minus x to the power alpha for all x belonging to 0 to 1, and we have to find f max. We have to find the f max value. So one way to do this question is simply finding f dash x and then finding out that if this is a maxima or a minima. So f dash x equals to 0. This implies alpha x to the power alpha minus 1 plus alpha into 1 minus x to the power alpha minus 1 into minus 1 is equals to 0. This implies alpha x to power alpha minus 1 is equals to alpha into 1 minus x to the power alpha minus 1. So when you do this calculations, you get x is equals to 1 minus x, which implies that x equals to 1 by 2. So x equals to 1 by 2 is a stationary point. Now one way to proceed from here is to calculate f double dash and then seeing the value of f double dash, deciding if half is a maxima or minima. But a better method in this scenario comes from the Weierstrass's theorem. So Weierstrass's theorem says that given a continuous function, which in this case f of x is, and over a bounded interval. So if you have a continuous function over a bounded interval, which in this case is 0 to 1, will have a maxima and a minima, and the only place for maxima and minima to exist are either the boundary points, which in this case are point 0, 1, or stationary points, which in this case is the point 1 by 2. So let us just check the value of f at these 3 points. F of 0, because x becomes 0 and 1 minus x becomes 1, this is 1 to the power alpha, which is 1. F of 1, because x becomes 1 and 1 minus x becomes 0, is again 1 to the power alpha, which is 1. And f of half is 1 by 2 to the power alpha plus 1 by 2 to the power alpha. So this is 2 by 2 to the power alpha. Now we have been given that alpha is a value between 0 to 1. Alpha strictly lies between 0 and 1. So 2 to the power alpha will be a value which is less than 2. So this implies 2 by 2 to the power alpha will be a value which is greater than 1. So hence our f of half is a maxima. So f of half gives a value of 1. So this is the f max that we have been looking for.